Over here in this question, I have a trapezium ABCD in which AB is parallel to DC. So this is my trapezium. These are the corners A, B, C, and D. And this line of AB is parallel to line DC. And the angle BAD is given to be 90 degrees. So this angle of BAD is 90 degrees. And the coordinates of A, B, and C are 2, 6, 5, -3, and 8, 3. In the first part of the question, I need to find the equation of the line AD. So I need to find the equation of this line. So to find the equation of the line, I'm going to use the formula of y minus y1 is equal to m times x minus x1. In order to use this formula, we need to know two things. The first is the gradient, and the second thing is any one point on the line whose x coordinate and y coordinate are both known to us. Let's first find the gradient. We know that the formula of the gradient is y2 minus y1 divided by x2 minus x1. But I can't use this formula to find the gradient of AD directly because on the line of AD, I only know one point, that is 2, 6. I don't know the coordinates of point D or any other coordinate on this line. And in order to use this formula, we need to know at least 2 points on a line. So what I'm going to do over here, I'm going to use the relationship of the line AB, which is like this, and the line AD. Both of these lines are perpendicular to each other. This is my line AB, and this is my line AD. These two lines are perpendicular to each other. And when two lines are perpendicular, the product of their gradients is equal to -1. So I can use this formula to find the gradient of AB first, and then use this relationship to find the gradient of the line AD. So let's first find the gradient of line AB. Let's name this point as x1, y1, and this as x2, y2. So the gradient AB would be equal to -3 minus 6 divided by 5 minus 2. -3 minus 6 is going to give me -9, and 5 minus 2 is going to give me 3, and -9 divided by 3 is -3. So the gradient of line AB is -3. Now I can use this relationship of m1 times m2 is equal to -1. So this would be -3 times m2, where m2 is the gradient of the line AD, is equal to -1. This comes out to be 1/3. So the gradient of the line AD is 1/3. Now the other thing required is any one point on the line whose equation I need to find. And I already know a point A on this line whose coordinates are 2, 6. So the point is already known to us. So now I can put these values in my equation, and the equation would become y minus y1, the y coordinate of the point that I'm using is 6. So y minus 6 is equal to m. The gradient we found was 1/3 times x minus x1, and the x coordinate of the point that I'm using is 2, so x minus 2. This would be equal to y minus 6 is equal to 1/3x minus 2/3. Adding 6 on both sides would give me y is equal to 1/3x minus 2/3 plus 6, and minus 2/3 plus 6 is equal to 16/3. So y is equal to 1/3x plus 16/3. This is my answer for the first part of the question. Now for the second part of the question, I need to find the coordinates of D. So I need to find the coordinates of this point. Well, I do know the equation of this line, and this point is the point of intersection of the line AD and the line of DC. Line AD and line DC are intersecting at this point over here, And to find the point of intersection, we solve the equation of the two lines simultaneously. I know the equation of the line AD, which I found in the first part, was y is equal to 1 upon 3x plus 16 upon 3. If I can find the equation of the line DC and solve these two equations simultaneously, I can find the coordinates of point D. Well, let's first find the equation of the line DC. To find the equation, I'm going to use this formula y minus y1 is equal to m times x minus x1. To use this formula, I need to know the gradient of the line DC and any one point on the line whose x coordinate and y coordinate are known. I do know the point on this line, that is point C. So I know this. I need to find the gradient of this line. Well, I know that this line and this line are both parallel to each other and the gradient of parallel lines is the same. So I can conclude from this that the gradient of this line is equal to the gradient of line AB, which we found was minus 3. So the gradient is equal to minus 3. Now I know both of these two, so I can put these in my formula. Y minus y1, the y coordinate of the point that I'm using is 3. So y minus 3 is equal to m times x minus x1, so minus 3 times x minus 8. This would become y minus 3 is equal to minus 3x plus 24 and y is equal to minus 3x plus 24 plus 3. 24 plus 3 is 27. So y is equal to minus 3x plus 27. This is the equation of the line of DC. Now to find the coordinates of point D, I am going to solve the equation of line DC and line AD simultaneously to find the coordinates of point D. The equation of line DC is y is equal to minus 3x plus 27 and the equation of line AD is y is equal to 1 upon 3x plus 16 upon 3. This is equation 1 and this is equation 2. I'm going to solve them by the method of substitution. Since y is already a subject in both of these equations, if I substitute equation 1 in equation 2, I'll get minus 3x plus 27 is equal to 1 upon 3x plus 16 upon 3. Shifting the terms with x on one side and the terms without x on the other side would give me 1 upon 3x plus 3x is equal to 27 minus 16 upon 3. 1 upon 3x plus 3x is equal to 10 upon 3x and 27 minus 16 upon 3 is equal to 65 upon 3. Now multiplying both sides of the equation by 3 would cancel these two 3's out and I'm left with x is equal to 65 upon 10, which is equal to 13 upon 2. So the x coordinate of point D is 13 upon 2 or 6.5. Now to find the corresponding y coordinate, I am going to substitute this value of x in either one of these two equations. Since equation 1 is more simpler, I'll put this in equation 1 and I'll get y is equal to minus 3 times 13 upon 2 plus 27. And if I put all of this in the calculator, I'll get 15 upon 2. So the y coordinate of point D is 15 upon 2. This was the answer to the second part of the question. Now let's look at the third part of the question. In the third part, it is told that there is some point E on this diagram such that ABCE is a parallelogram and I need to find the length of BE. Well, we know that a parallelogram looks like this. The opposite sides are parallel to each other. But over here, we are given a trapezium. If I draw this trapezium over here, it looks something like this. This is point A and this is point B. This is point D and this is point C. Well, we know that these two lines are parallel to each other, but these two are not parallel to each other. So if I introduce a point E somewhere over here such that these two lines become parallel to each other, this would form a parallelogram. So I can say that my point E is somewhere on the north side of point D. This is point E. Now point E is the point of intersection of line AE and line EC. And line EC is going to have the same equation as line DC because DC is on the same line as line EC. So the line EC is going to have the equation of y is equal to minus 3x plus 27. And in the third part, I need to find the length of BE. But first, to find the length of BE, I need to first find the coordinates of point E. And to find the coordinates of point E, I am going to solve the equation of line AE and line EC simultaneously, because point E is the point of intersection of these two lines. I don't know the equation of line AE, so that I need to find. So for equation of line AE, I'm going to use the formula for equation, which is y minus y1 is equal to m times x minus x1. I know the gradient of these two lines is going to be the same because these two are parallel to each other. I don't know the gradient of BC, so let's find the gradient of BC. M BC would be equal to, let's name this as x1 y1 and this as x2 y2. So the gradient would be y2 minus y1, so minus 3 divided by 5 minus 8. This would be minus 6 upon minus 3, which is equal to 2. So the gradient of line BC is positive 2, and that is equal to the gradient of line AE. Now I already know the point on this line, that is this point A that has the coordinates of 2, 6. So I can go on and find the equation of this line. The equation would be y minus, the y coordinate is 6, so y minus 6 is equal to m, the gradient we found was 2, so 2 times x minus x1, so x minus 2. This would be y is equal to 2x minus 4 plus 6, which is equal to y is equal to 2x plus 2. This is the equation of this line of AE. Y is equal to 2x plus 2. Now let's solve these two equations simultaneously. This is equation 1, this is equation 2. I am going to solve them by substitution since y is already a subject in both of these equations. If I substitute 1 into 2, I'll get 2x plus 2 is equal to minus 3x plus 27. Sending 3x on this side, 2 on that side, I'll get 2x plus 3x is equal to 27 minus 2. This would be 5x is equal to 25, and I'll get x as 5. For the corresponding y coordinate, I'm going to plug this x in equation 1, and I'll get y is equal to 2 times 5, which is 10, 10 plus 2, and I'll get y as 12. So the y coordinate is 12. So these are the coordinates of point E, which are 5, 12. Now to find the length of BE, I know the coordinates of point B, which are 5, minus 3, and I know the coordinates of point E, which are 5, 12. To find the distance between these 2 points, the formula of distance is x2 minus x1 whole square plus y2 minus y1 whole square and under root on the top. Let's name this as x1 y1 and this as x2 y2. I'll get the distance is equal to x2 is 5 and x1 is also 5, so 5 minus 5 whole square plus y2 is 12 and y1 is minus 3 and whole square under root on top. 5 minus 5 is 0, so this all would go to 0, and minus times minus 3 is going to be positive 3, so this would become 12 plus 3 whole square. Now since there is only one term inside the square root, this square and this under root cancel each other out, and I'm left with the distance as 12 plus 3, which is 15. So the length of BE is 15 units. This is my answer to the third part of the question.